There are moments in human history when a single fleeting observation forces us to redraw the map of reality. A ship appearing on a horizon once thought to be the edge of the world. A microscopic organism squirming in a drop of water, revealing an invisible universe teeming with life. And then there is the silent visitor of 2017, a ghost in the cosmic machine. For a few brief weeks, our solar system, the only home we have ever known, was host to an enigma. It arrived unannounced from the cold, dark void between the stars, looped around our sun with impossible grace, and then vanished back into the interstellar night, leaving behind a trail of unanswered and perhaps unanswerable questions. We gave it a name from the land of its discoverers, Oumuamua. In Hawaiian, it means a messenger from afar arriving first, a name that would prove to be more prophetic, more haunting than anyone could have possibly imagined. Because the central question that still hangs in the air, years later, is this: what was the message? Was it a naturally occurring cosmic driftwood, a testament to the random, chaotic beauty of the universe? Or was it something else? A deliberately manufactured object, a piece of technology from a civilization unknown, a silent, passing testament to the fact that we are not, and perhaps never have been, alone. This question has created a schism in the world of astronomy, a quiet war fought in scientific papers and academic conferences. On one side, the search for a natural explanation, no matter how exotic. On the other, the chilling hypothesis of an artificial origin. For years, this debate was a stalemate, a philosophical deadlock based on the scant data we could gather from that fleeting encounter. But what if that has changed? What if a new set of eyes, a tireless all-sky sentinel built not for finding aliens, but for protecting Earth from asteroids, has stumbled upon the clue that breaks the case wide open? This is the story of that clue. This is the story of how the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a humble planetary defense network, may have inadvertently become the key witness in the most profound investigation in human history. This is the Oumuamua conspiracy, and what we are now finding is changing everything we thought we knew. To understand the revolution, you must first understand the crime scene. October 19, 2017. The Panoramic Survey Telescope and Rapid Response System, PAN-CARRS-1, perched atop Haleakala in Hawaii, flags a faint point of light moving rapidly across the sky. At first, it's just another data point in an endless stream, a 10 BML2. But as astronomers traced its path backwards, a shocking realization dawned. This object's trajectory was not a closed loop, an ellipse binding it to our sun. It was a hyperbola, an open-ended path. It was a tourist. It had come from beyond, from the direction of the star Vega, though not from Vega itself, as the journey would have taken hundreds of thousands of years. It was our first confirmed interstellar visitor. Think about what that means. For all of recorded history, the heavens were a family affair. Every comet, every asteroid, every planet was a member of our solar system, born from the same protoplanetary disk. They were us. Oumuamua was the first confirmed them. It was the cosmic equivalent of an isolated tribe living on an island for millennia, suddenly finding a thermos flask washed up on their shore. The immediate challenge was to classify it. What was this thing? The first assumption was that it was a comet, the most likely type of object to be ejected from a distant star system. But as telescopes around the world swiveled to get a look, the mystery only deepened. It showed no signs of being a comet. There was no coma, that beautiful fuzzy halo of gas and dust that erupts as a comet warms up near the sun. It was inert, clean. So it must be an asteroid then, a rocky, interstellar asteroid. This became the working hypothesis. But then came the most baffling clue of all. As Oumuamua looped around the sun and began its journey back out into the void, astronomers at the Hubble Space Telescope measured its position with exquisite precision. And they found something that should not have been there. It was accelerating. Ever so slightly, it was pushing away from the sun with a force that gravity alone could not explain. This is called non-gravitational acceleration, and it's the smoking gun for a comet. The invisible outgassing of sublimating ices acts like a tiny natural rocket engine, giving the comet a gentle push. But we had already looked for that gas. We had used the Spitzer Space Telescope. We had used radio arrays. We found nothing. No water, no carbon monoxide, nothing. It was accelerating without a tailpipe. It was a ship moving without a visible engine. This is where the scientific story splits into two distinct paths, where the investigation becomes a conspiracy. The first path is the path of the exotic natural. Faced with a set of contradictory facts, it moves like a comet, but it looks like an asteroid. Scientists began proposing ever more complex and exotic natural explanations. Perhaps it was made of something we'd never considered, like a giant iceberg of solid hydrogen, which would outgas invisibly. This theory was quickly challenged, as a hydrogen iceberg would likely have evaporated long before it ever reached us. Then came a more robust, and for a time, leading hypothesis: a nitrogen iceberg. The idea was that a chunk of a Pluto-like planet, rich in frozen nitrogen, had been sheared off in some cataclysm and flung into interstellar space. The nitrogen would sublimate, providing the mysterious push, but the gas would be difficult to detect with our instruments. It was an elegant, clever solution. It preserved the naturalistic worldview. It meant the thermos flask was just an unusually shaped coconut. But it required a whole chain of undiscovered phenomena to be true. It required the existence of a vast, unseen population of these nitrogen planets, or Plutoids, around other stars. It required a mechanism to chip off fragments of just the right size and send them our way. It was, in essence, an attempt to solve a mystery by invoking a bigger, unproven mystery. It was a desperate search for a natural explanation, because the alternative was simply too uncomfortable for many to contemplate. And that brings us to the second path, the path less traveled, the path of the artificial. This path was championed most famously by Avi Loeb, then the chair of Harvard's astronomy department. His argument was a form of Occam's razor, the principle that the simplest explanation is often the correct one. What if, he argued, we stopped trying to force Oumuamua to be a type of natural object we'd never seen before, and instead considered the possibility that it was a type of artificial object that we have already conceived of? The object was long and flat, based on how its brightness tumbled. It was being pushed by the sun. What do we know of that is long, flat, and pushed by the sun? A solar sail, a light sail, a technology that our own civilization is actively developing as a means of interstellar travel. The non-gravitational acceleration wasn't from some invisible gas. It was the gentle, persistent pressure of sunlight itself pushing against a vast, thin surface. In this view, Oumuamua wasn't a nitrogen iceberg from a fictional planet. It was a piece of alien technology. Perhaps a probe, a buoy, a piece of debris, or the interstellar equivalent of a shipwreck. This was not a claim that it was a spaceship full of aliens. It was a sober assessment that, given the strange confluence of evidence, an artificial origin was a more parsimonious explanation than inventing new categories of cosmic objects with no other evidence for their existence. This right here is the heart of the conspiracy. Not a conspiracy of governments hiding UFOs, but a conspiracy of thought. A deep, institutional, and perhaps necessary conservatism in the scientific community that recoils from any explanation that hints at extraterrestrial intelligence. The hypothesis was deemed sensationalist, unscientific. It was easier to invent an entire new class of planet than to confront the possibility that the thermos flask was, in fact, a thermos flask. And for years, the debate remained there, frozen, a bizarre one-off event with two irreconcilable schools of thought. That is, until the Sentinels came online. Enter Atlas. The asteroid terrestrial impact last alert system is not like the telescopes that first saw Oumuamua. It wasn't designed for deep, philosophical discoveries. It has a blue-collar job, to be our planetary bouncer. Comprised of 4 telescopes in Hawaii, Chile, and South Africa, A TLAS scans the entire visible sky every 24 hours. Its job is to find rocks that are coming to hit us, to give us a last alert. It is a wide net fishing operation, not a deep sea submarine expedition. It doesn't stare intently at one patch of sky. It surveys everything, constantly. And in doing so, it has become the most prolific comet finder in modern history. This is where our story pivots. This is the new evidence. The initial hope for those on the exotic natural path was that Atlas would soon find more objects like Oumuamua. They hoped it would find a whole family of these tailless, accelerating interstellar visitors, proving they were a common natural phenomenon. If we started seeing one every year, the mystery would be solved. Oumuamua wasn't special. It was just the first of a new category. But that's not what happened. In 2019, another interstellar visitor was found, this time by amateur astronomer Gennady Borisov. We named it 2I Borisov, and it was perfectly normal. It was a textbook comet with a huge, glorious coma and tail. It behaved exactly as expected. It was the proof of concept for a natural interstellar object. And since then, Atlas and other survey telescopes have been watching. They have cataloged thousands of objects. They have refined our understanding of the traffic moving through our cosmic neighborhood. And what Atlas has found, the discovery that changes everything, is a profound, deafening silence. It has not found any more Oumuas. It has found no nitrogen icebergs. It has found no hydrogen comets. Every other interstellar object, every other comet from the far-flung Oort cloud of our own solar system, behaves by the rules. They outgas. They have comas. The more data Atlas provides, the more it gives us a statistical baseline for what is normal. The more Oumuamua stands out in horrifying, stark isolation. The new data, meant to make Oumuamua mundane, has instead cemented its status as a true anomaly. The conspiracy is not that Atlas has found proof of aliens. The conspiracy is that the data it is gathering is systematically dismantling every single natural explanation proposed for our first visitor. It is eliminating all the other suspects, leaving only one. In the cosmic courtroom, the evidence Atlas is providing isn't giving Oumuamua an alibi. It is removing everyone else's. And so we must reopen the case. We must look again at that fleeting messenger, not as an oddity to be explained away, but as a paradigm-shifting clue that demands our full attention. The question is no longer just, what was it? The question Atlas forces us to ask is, if it was artificial, what does that mean for us? And when is the next one coming? Before we analyze the celestial clues, we must first turn our investigative lens inward. An event has no meaning without an observer, and the story of Oumuamua is as much about the object itself as it is about the civilization that witnessed it. Who were we in the year 2017? What were the hopes and fears that shaped our reaction to this silent passerby? To understand the conspiracy, we must first understand the psychological landscape, the cultural soil in which its seeds were planted. We were a civilization in paradox. We had achieved technological omnipotence, holding devices in our hands that connected us to the entirety of human knowledge, yet we felt increasingly powerless. We were living in an age of unprecedented information, yet simultaneously drowning in a fog of misinformation, alternative facts, and deep-seated distrust in the very institutions that were the bedrock of progress. We had become a species of skeptics, primed to question any official narrative, whether it concerned politics, medicine, or the cosmos itself. It was the perfect environment for an enigma like Oumuamua to arrive. It did not appear in the confident, optimistic world of the 1960s space race. It appeared in our world, a world of fractured trust and digital anxiety, where the line between a grand conspiracy and a mundane explanation had become dangerously blurred. Our relationship with the sky itself was schizophrenic. On one hand, we were living through a golden age of astronomy. The Hubble Space Telescope and later the James Webb were feeding us a daily diet of cosmic splendor, images of such profound beauty they bordered on the divine. We saw stellar nurseries birthing new suns, galaxies colliding in a silent, slow-motion dance, and we peered back to the dawn of time itself. Space was a source of wonder, a canvas for our grandest dreams. But on the other hand, the sky was a source of profound existential dread. The very science that showed us the beauty also showed us the danger. We were acutely aware of the threat of asteroid impacts, the kind of civilization-ending events that our new Sentinel Atlas was built to prevent. We knew about the destructive power of solar flares, the eventual death of our own sun, the sheer, crushing hostility of the vacuum. We were like a family living in a magnificent glass house, mesmerized by the beautiful, sweeping vistas of the wilderness outside, but also acutely aware that the wilderness was filled with predators and that the glass could shatter at any moment. This duality of wonder and terror is the emotional signature of our time. We looked to the stars with hope for connection and fear of annihilation. And into this tense, expectant silence, Oumuamua drifted. It was a Rorschach test, a cosmic inkblot, and what we saw in it said more about us than it did about the object. This existential tension was not new. It was the culmination of a search that had formally begun decades earlier. This is the story of SETI, the search for extraterrestrial intelligence. Since the mid-20th century, we have been systematically listening. We have built colossal radio dishes, electronic ears, cupped to the heavens, straining to hear a single, structured, unnatural whisper in the cosmic static. From Frank Drake's pioneering Project Ozma to the modern Allen Telescope Array, the effort has been a testament to a uniquely human quality, a hopeful loneliness. It is an admission that for all our knowledge, for all our art and science, the grandest question remains unanswered. Are we it? Is this thinking, dreaming, self-aware consciousness that has arisen on this small, wet rock a unique, freak accident? Or is it a common flowering of the universe's potential? We even tried shouting into the void ourselves. The Arecibo message of 1974 was a simple pictogram, a digital cave painting launched towards the globular star cluster M13. It contained our numbering system, the atomic numbers of our core elements, a diagram of our DNA, a rough sketch of a human being, and a map of our solar system. It was a message in a bottle cast into a cosmic ocean, a hopeful gesture that someone, somewhere, might one day find it and know they were not alone. But the defining characteristic of this entire multi-generational search has been its result, an unnerving, profound, and absolute silence. This is the great cosmic mystery known as the Fermi paradox. The physicist Enrico Fermi famously asked, given the vast number of stars and Earth-like planets that our calculations predict, where is everybody? The galaxy should be teeming with life, much of it billions of years older than us. It should be humming with the signals of countless civilizations. It should be littered with probes, artifacts, and the engineering projects of Kardashev Type 2 and 3 civilizations. Yet, we see nothing. We hear nothing. The universe, as far as we can tell, is empty and silent. This silence has forced us to confront a host of disturbing possibilities, dark solutions to Fermi's question. The most famous is the idea of a great filter. This theory posits that there is some barrier, some incredibly difficult step in the evolution of life and intelligence that is almost impossible to overcome. Perhaps the jump from single-celled to multi-celled life is the filter. Or perhaps the filter is ahead of us. Perhaps all civilizations that develop technology inevitably destroy themselves through nuclear war, environmental collapse, or some other self-inflicted catastrophe. We might be the most advanced civilization in the galaxy simply because everyone else has already failed. Then there is the even more chilling hypothesis, popularized in recent fiction, but with roots in serious scientific thought, the dark forest theory. This solution to the paradox suggests that the universe is indeed full of intelligent life, but it is silent because it is terrified. In a dark forest full of unknown hunters, the only winning move is to stay hidden. To broadcast your existence is to invite your own destruction by a more powerful predator. In this scenario, the silence of the cosmos is not an absence of life, but a cacophony of fear. Now, place Oumuamua within this context. It wasn't the friendly, talkative alien we had been hoping for. It wasn't the Arecibo message answered. It was silent. It ignored our planet, our sun, our existence. It betrayed no sign of its purpose or origin. If it was a natural object, this silence is meaningless. But if it was an artifact, its silence becomes a terrifying piece of data. Was it a probe that, upon observing us, decided we were not worth contacting, a cosmic tourist passing by a dull exhibit? Or was it deliberately silent, running a passive surveillance program, a scout ship operating under the grim logic of the dark forest, observing the hunters without revealing its own position? The arrival of Oumuamua did not resolve the Fermi paradox. It deepened it. It presented us with the ghost of a solution, a disquieting hint that the silence might not be because no one is out there, but because the ones who are out there have very good reasons to be quiet. And who are the people grappling with this cosmic dilemma? They are not a monolith. The scientific community that observed Oumuamua is a culture of human beings, driven by the same cognitive biases and emotional currents as the rest of us. The debate over its nature is a profoundly human story. On one side, you have the establishment, the majority of the astronomical community. These are the guardians of the scientific method, a method that is inherently conservative and for good reason. It is a system designed to protect us from our own biases, from our desire to believe. The principle of requiring extraordinary evidence for extraordinary claims is not a sign of a lack of imagination. It is the single most powerful tool we have for finding the actual truth. When they proposed nitrogen icebergs or hydrogen comets, they were not engaging in a cover-up. They were doing their job. They were attempting to stretch the boundaries of known physics to accommodate a new data point, which is a far more responsible first step than throwing out the entire rulebook. This camp represents the Apollonian aspect of our nature: reason, order, skepticism, and the slow, methodical accumulation of evidence. On the other side, you have the dissenters, personified by figures like Avi Loeb. This camp represents the Dionysian spirit, intuition, imagination, and the courage to challenge orthodoxy. Loeb's argument was that the scientific establishment's conservatism was, in this unique case, becoming a form of blindness. By refusing to even seriously entertain the artificial hypothesis, they were failing to follow the evidence where it led. They were, in his view, behaving like a detective who, having found a bullet casing at a crime scene, insists it must be a new type of fossilized shell because he doesn't believe guns exist. This is not a story of heroes and villains. It is the story of an essential eternal tension in the human quest for knowledge. We need both the skeptic and the visionary. We need the guardians who protect the integrity of the process, and we need the trailblazers who force the guardians to look in new directions. Oumuamua did not just challenge our models of the solar system. It challenged our model of science itself, forcing us to ask, at what point does healthy skepticism become a failure of imagination? Finally, we must acknowledge the invisible framework that shaped this entire encounter, a century of science fiction. None of us came to the Oumuamua event with a clean slate. Our minds have been populated with images and narratives from H.G. Wells to Star Wars, from 2001, A Space Odyssey to Arrival. We have a pre-written script for what first contact is supposed to look like. It's supposed to be momentous, unambiguous. A giant ship appears over a major city. We receive a clear, mathematical signal. A mysterious, awe-inspiring monolith is discovered on the moon. Contact is an event. It is intentional. It is directed at us. Oumuamua violated every single one of these cultural expectations. Its arrival was subtle, almost missed. It was ambiguous. Its nature still debated years later. It showed no interest in us whatsoever. It wasn't a greeting or an invasion. It was an act of supreme cosmic indifference. And this, perhaps, is the most profound cultural shock it delivered. The possibility that the universe is not only populated by others, but that we are cosmically irrelevant to them. The thermos flask on the beach wasn't a message for the tribe. It was just trash, dropped from a ship that sailed by without even noticing the island was there. This idea is a deep challenge to our species' inherent narcissism. We are the protagonists of our own story, and we naturally assume we must be the protagonists of the cosmic story too. Oumuamua suggests we might not even be a footnote. This was the terrestrial context. We were a hopeful, fearful, suspicious, and science fiction-saturated civilization. We were a people desperately searching for our place in the cosmos, and we were suddenly presented with a clue that was maddeningly, perfectly, incomprehensibly ambiguous. And it is from this cultural crime scene, littered with our own psychological fingerprints, that the real investigation must now begin. Every great investigation begins at the scene of the crime. But in this case, the crime scene was 400 million kilometers of empty space, and the suspect was moving at 87 kilometers per second. The investigation into Oumuamua was not a calm, methodical study. It was a frantic, desperate sprint against the unforgiving clockwork of orbital mechanics. The most crucial fact to understand is that we were late to the party. By the time the Pan-STARRS telescope in Hawaii first spotted it, Oumuamua had already completed its closest approach to the Sun. It had already swooped inside the orbit of Mercury, swung around our star, and was heading back out away from us forever. It was discovered on the retreat. Imagine a detective arriving at a crime scene only to see the getaway car disappearing over the horizon. The window of opportunity to gather evidence was not months or years. It was a matter of weeks, fading to days, and then hours. A global astronomical emergency was declared, not with sirens, but with the silent swiveling of giant telescopes. The Very Large Telescope in Chile, the Gemini Observatory, the Hubble and Spitzer Space Telescopes instruments designed for years-long projects were suddenly redirected, their schedules cleared for a single fleeting target. The challenges were immense. The object was tiny, estimated to be no more than a few hundred meters across, and it was dark, reflecting perhaps only 10% of the sunlight that hit it. It had the reflectivity of asphalt. Trying to study, it was like trying to analyze the chemical composition of a lump of charcoal from across a continent while it was being fired from a cannon. Every photon of light captured was a precious, irreplaceable clue. And from this mad scramble, 4 key pieces of evidence emerged. 4 celestial clues that would form the foundation of this entire cosmic mystery. Clue number 1, the trajectory. This was the passport, the undeniable proof of its origin. When astronomers first plotted its course, they calculated a number called its orbital eccentricity. For any object bound to our sun, a planet, an asteroid, a comet, that number is less than 1, describing a closed elliptical path. The object is on a leash. Oumuamua's eccentricity was 1.2. This number, a dry piece of orbital data, was the scientific equivalent of a thunderclap. An eccentricity greater than 1 describes a hyperbola, an open-ended path. This object was not on a leash. It was a bird flying straight through the yard, never to return. It was not a prodigal son returning from the cold outer solar system. It was an immigrant from another shore entirely. By tracing its path backward, astronomers determined it had entered our solar system from the direction of the bright star Vega in the constellation Lyra. While it did not come from Vega, the travel time of 300,000 years means Vega wasn't in that position when the journey began. It gave us a direction, a point of origin on the galactic map. This was the first and most important piece of the puzzle. It fundamentally changed the game. Before this moment, every object we had ever studied in space was one of us. This clue proved, with the certainty of mathematics, that Oumuamua was one of them. It was the first time we had ever held a piece of another star system in our hands, metaphorically speaking. And this fact alone justified the frantic scramble to learn everything we possibly could before it was gone. Clue number 2, the light curve. This was the bizarre fingerprint, the hint of an impossible shape. Because Oumuamua was too small and too far away to ever be seen as anything more than a point of light, astronomers had to be clever. They studied its light curve, which is simply a graph of its brightness over time. If you watch a spinning sphere, its brightness stays relatively constant. But if you watch a long oblong object tumbling end over end, its brightness will vary dramatically as you see its long side and then its narrow end. The light curve of Oumuamua was unlike any we had ever seen. Its brightness changed by a factor of 10 every 7 to 8 hours. The variation was so extreme that it could only mean one thing: the object had a very, very strange shape. The initial interpretation, which captured the world's imagination, was that it was long and thin, like a cigar or a needle, perhaps 10 times longer than it was wide. No known asteroid or comet looks like this. The forces of gravity and celestial mechanics tend to shape objects into roughly spherical or lumpy, potato-like forms. There is no known natural process that would create a perfect interstellar cigar. Later, more refined analysis offered an alternative, equally bizarre possibility. The object wasn't a cigar, but a pancake. It could be a flat, disc-like or shard-like object, tumbling like a coin thrown in the air. This, too, was a shape with no natural precedent. Why is this so important? Because it was the first clue that Oumuamua was not just an interstellar visitor, but an anomalous one. If it had been a roughly spherical rock on a hyperbolic path, it would have been a fascinating but understandable discovery. But this was a rock with a shape that defied our understanding of how cosmic objects are formed. The passport said it was from out of town, but its physical appearance suggested it was from a part of town we couldn't even imagine. Clue number 3, the spectrum. This was the silent witness, the clue defined by an absence of evidence. Using the giant telescopes in Chile and Hawaii, astronomers performed spectroscopy on the faint light from the object. This technique works like a prism, breaking light down into its constituent colors to find the chemical fingerprints of different elements and compounds. This is how we know what stars are made of and what atmospheres on other planets contain. The spectrum of Oumuamua was, once again, baffling. It was reddish in color, consistent with many objects in our own outer solar system that have been sunburned by eons of exposure to cosmic rays, creating complex organic molecules called tholins on their surface. But beyond that, its spectrum was frustratingly featureless. There were no clear, distinct absorption lines that would scream water ice or olivine or any other specific mineral. It was a clean, almost generic reddish signature. Most importantly, this spectral analysis, combined with deep observations from the Spitzer Space Telescope, which looks in the infrared, confirmed what we already suspected. There was no coma. There was no cloud of sublimating gas, no dust, no water vapor, nothing. Spitzer is so sensitive it could have detected even a tiny amount of carbon monoxide or carbon dioxide outgassing, but it saw zero. This clue is absolutely critical. It's the prosecution's star witness. The light curve suggested it wasn't a typical rock, and the spectrum now suggested it wasn't a typical comet. Comets are defined by their comas. They are dirty snowballs that vent gas as they approach the sun. This object was clean. It was inert. And this fact created a direct and irreconcilable contradiction with the final, most important clue. Clue number 4, the acceleration. This was the ghost in the machine, the impossible engine. This is the clue that elevates the case from a cosmic curiosity to a potential paradigm shift. As the Hubble Space Telescope tracked Oumuamua's departure with unparalleled precision, it confirmed a tiny, but statistically undeniable, deviation in its path. It was not following the perfect, elegant arc dictated by the sun's gravity alone. It was being pushed. Something was giving it a small but persistent nudge, accelerating it away from the sun. As we have established, this kind of non-gravitational acceleration is the calling card of a comet. The outgassing of jets of gas and dust acts like a natural rocket engine. But we had already proven, with clue number 3, that there was no gas and no dust. It was being propelled by a phantom engine. This is the central paradox of the Oumuamua mystery. It accelerated like a comet, but had none of the physical properties of a comet. The various natural explanations, like the nitrogen iceberg, were attempts to resolve this very paradox. But what if we take the data at face value? What known force pushes objects away from the sun without creating a visible coma? There is one: solar radiation pressure. The photons of sunlight themselves exert a tiny physical force. For a large, dense object like an asteroid, this force is negligible. It's like a fly trying to push a bowling ball. But if an object were very low density, or more specifically, if it had a very large surface area compared to its mass, the push would become significant. What kind of object has a large area and a low mass? A sail. The numbers were crunched. The observed acceleration was perfectly consistent with the physics of a thin, shard-like object being pushed by the sun. The data fit the profile of a light sail. This isn't a conclusion. It is a celestial clue, a hard data point. Laid out on the detective's table, the evidence is now clear. We have a passport from another star. We have a description of a suspect with an impossibly strange body. We have a forensic analysis that shows a clean surface with no residue. And we have a clear measurement of an engine, a force, that left no chemical trace. These are the facts of the case. These are the celestial clues. The task ahead is to connect these strange, cold, cosmic facts to the warm, biased, human context we have already established. The moment of eureka is when these two worlds collide. This is the pivotal moment in any investigation. The point where the scattered pieces of evidence, the contextual clues, and the witness testimonies must be woven into a single, coherent narrative. We have explored the crime scene, the cold, hard data of the celestial clues. And we have profiled the witness, our own anxious, hopeful, and biased civilization. Now we must connect them. The paradox we are left with is stark. An object that accelerates like a comet, but shows no cometary activity. An object with a shape that seems to defy natural formation. An object with an interstellar passport. How can all of these truths coexist? This is the cosmic equivalent of a locked room murder mystery. The body is on the floor. The door is locked from the inside. The windows are barred. The official explanation would be to posit a new, unknown natural cause of death, like spontaneous human combustion. It's an attempt to explain the unexplainable by inventing an even bigger unknown. The alternative, the conspiracy theory, is to suggest that our understanding of the room itself is flawed, that there is a mechanism, a technology, a hidden passage that we haven't yet accounted for. The nitrogen iceberg hypothesis is the scientific equivalent of spontaneous combustion. The artificial light sail hypothesis is the hidden passage. For years, we have been caught between these two possibilities, a stalemate of the imagination. But this is where our new evidence, our star witness, changes the nature of the investigation. This is where Atlas provides the key to the locked room. To build our thesis, we must first critically examine the alternative. Why does the leading natural explanation, the nitrogen iceberg theory, ultimately fail to satisfy? The theory was born from a place of intellectual necessity. It was an ingenious attempt by brilliant scientists to resolve the acceleration paradox without resorting to the extraordinary claim of alien technology. This aligns perfectly with the terrestrial context we explored. It is an expression of science's healthy, necessary skepticism. But a good hypothesis must do more than just solve one problem. It must be plausible in its own right and not create more problems than it solves. Here, the nitrogen iceberg theory begins to falter. First, it requires a source. It posits that a vast, unseen population of Pluto-like planets, so-called exoplutos, must be common throughout the galaxy. We have no direct evidence for this. Second, it requires a specific and violent mechanism to chip off a fragment of pure nitrogen ice from one of these planets and eject it into interstellar space. Third, And perhaps most critically, subsequent studies have shown that such a nitrogen iceberg would have evaporated far too quickly during its immense journey through the galactic radiation environment. It would be like an ice cube trying to cross a desert. By the time it reached our solar system, there would have been little left of it. So, while the theory elegantly explains the lack of a visible coma and the mysterious acceleration, it does so at the cost of invoking a chain of unproven and improbable events. It is a solution that feels more complex than the original mystery. It is a story we told ourselves because the alternative was too uncomfortable to face. Now, let us walk down the other path. Let us, for a moment, suspend the institutional bias against the artificial and apply Occam's razor. What is the simplest explanation that fits all the known facts? Let's take our celestial clues, one by one, and test them against the hypothesis that Oumuamua was a piece of extraterrestrial technology. First, the impossible shape, inferred from the extreme light curve. An object 10 times longer than it is wide, or a flat, pancake-like shard. Is this shape hard to explain for an asteroid? Yes. Is it hard to explain for a piece of technology? No. In fact, a thin, wide shape is precisely what you would engineer for a solar sail, to maximize surface area while minimizing mass. The shape is not an anomaly. It's a design feature. Second, the lack of a coma, the clean spectral signature. Does this contradict the comet hypothesis? Absolutely. Does it contradict the technology hypothesis? No. An object made of metal, ceramic, or advanced composite materials would not outgas as it warmed. Its inertness is exactly what we would expect from a manufactured object. Third, its interstellar origin. While natural objects can be ejected from star systems, sending a probe or a ship on a deliberate interstellar journey is the hallmark of an advanced spacefaring civilization. Its trajectory is consistent with its function. Finally, and most importantly, the non-gravitational acceleration, the ghost in the machine. As we've established, this is the central paradox for any natural explanation. But for the artificial hypothesis, it is the opposite. It is the confirmation. The gentle, persistent push away from the sun, with no visible exhaust, is not a mystery. It is the very definition of how a light sail works. It is the single clue that turns the key. One single, admittedly extraordinary hypothesis that the object was manufactured simultaneously and elegantly explains every single anomalous data point. There is no need to invent exoplutos or new types of cosmic icebergs. The locked room is opened with a simple realization. The killer had a key we didn't know existed. This is where the debate stood for years. An improbable natural theory versus a simple but paradigm-shattering artificial one. A classic stalemate. It was a single data point, an N of one. It was impossible to know if Oumuamua was a true freak, a 1 in a trillion cosmic accident, or if it was the first representative of a vast, unseen population of similar objects. This is the argument the naturalists clung to. It's weird, but we'll find more like it, and then it won't be weird anymore. And this is precisely where Atlas enters the story and demolishes the stalemate. This is the connection. This is the thesis. The game-changing discovery of the A2LAS survey is not a single dramatic photograph. It is a quiet, relentless, statistical truth. The job of Atlas is to map the traffic in our solar system. And in the years since Oumuamua, it has done just that, discovering hundreds of comets and asteroids. It helped characterize our second interstellar visitor, 2I Borisov, which was a perfectly normal, well-behaved comet. It is giving us the background check on the cosmos. It is showing us what normal looks like. And the revolutionary, universe-altering finding from Atlas is the deafening silence. It has found 0 other Oumuamua. It has found no other tailless objects that accelerate. It has found no evidence of a vast fleet of nitrogen icebergs crossing the void. The core argument for the naturalists that Oumuamua was the first of many is being systematically dismantled with every day that Atlas operates. The conspiracy, therefore, is not one of hidden information, but have ignored implications. The very tool that was supposed to normalize Oumuamua is doing the exact opposite. It is sharpening its uniqueness. It is highlighting its profound abnormality. Imagine finding a single, perfectly cut diamond on a beach. It's a mystery. You could hypothesize that some unknown geological process creates cut diamonds. But if you then spend 5 years meticulously sieving every grain of sand on that beach and find millions of pebbles, shells, and sea glass, but not a single other diamond, your initial hypothesis is weakened, not strengthened. The diamond now looks even more out of place. Atlas is sieving the solar system, and it is finding only pebbles and shells. The diamond Oumuamua remains utterly, stubbornly unique. The thesis of our investigation can therefore be stated. The confluence of celestial clues, its shape, its cleanliness, its acceleration points strongly towards an artificial origin. This conclusion was initially resisted due to a deep-seated and understandable cultural and scientific bias. A terrestrial context prefers any natural explanation, no matter how convoluted, to an artificial one. The stalemate between these two viewpoints persisted because Oumuamua was a singular event. But now, the ongoing comprehensive sky surveys, spearheaded by systems like Atlas, have provided the tie-breaking evidence. This evidence is the statistical absence of similar natural objects. By showing us what is common, Atlas has fundamentally changed our understanding of what is rare. It has transformed Oumuamua from a potential prototype into a confirmed anomaly. Our thesis is that the Atlas data, in its silent statistical power, has closed the case for the naturalistic explanations and has left the artificial hypothesis as the most logical, parsimonious, and scientifically sound explanation for the facts we have before us. We are now confronting the very real possibility that in 2017, humanity was visited by a piece of extraterrestrial technology, and the evidence has been hiding in plain sight all along. The question that remains is the most important one of all. What is the impact of that conclusion? If our thesis is correct, what happens next? What is the impact of knowing that the first confirmed visitor from another star system was not a rock, but a piece of technology? The answer is simple and profound. Everything changes. The acceptance of this conclusion represents not just a scientific breakthrough, but a turning point for our species, a philosophical rupture on par with the Copernican revolution. For millennia, humanity has operated under two fundamental assumptions: that the Earth was the center of the universe, and that humanity was the sole proprietor of intelligence. Copernicus and Galileo shattered the first assumption, demoting our world to just another planet orbiting an average star. This was a blow to our ego, but it expanded our universe. Charles Darwin shattered the second, demoting our species from a divine creation to a single, clever branch on the sprawling tree of life. This was a blow to our sense of specialness, but it connected us to the deep, beautiful story of biology. The thesis of Oumuamua's artificial origin presents us with the third and perhaps final great demotion. We are not the only minds in the universe. Our intelligence is not a singular, miraculous event, but just one local expression of a cosmic phenomenon. This is the ultimate shattering of our cosmic loneliness, and its impact will reshape our religion, our centers of power, and the very fabric of our society. It is the beginning of a new chapter in the human story, a chapter in which we no longer refers to just humanity, but to our place within a populated and vastly more interesting cosmos. The most immediate and tangible legacy is already taking shape in the world of science. The passage of Oumuamua was a wake-up call. It was a fire alarm in the night. For 60 years, our search for extraterrestrial intelligence was almost entirely passive. SETI was a search for whispers, for radio signals deliberately or accidentally sent our way. We were waiting for the phone to ring. Oumuamua taught us that the messages might not be whispers at all. They might be physical objects. It created an entirely new field of inquiry, interstellar archaeology. The search is no longer just for signals, but for artifacts. This has led to the birth of a new kind of science, a more active and audacious search. The most prominent example is the Galileo project, spearheaded by the very same astronomer who championed the artificial hypothesis, Avi Loeb. The project's stated mission is to bring the search for extraterrestrial technological signatures from the ray fringes into the mainstream of scientific research. It aims to build a network of advanced telescopes and instruments dedicated to one purpose: to find and characterize objects like Oumuamua. It is a direct and explicit legacy. We are no longer content to stumble upon these visitors by accident with telescopes designed for other purposes. We are now building the tools specifically to hunt for them. We are turning our planetary defense systems, like Atlas, into the first line of a cosmic detective agency. We are actively looking for the next piece of evidence. And what happens when we find it? An even more ambitious legacy is being planned: Project Lyra. Conceived by the Initiative for Interstellar Studies, it is a mission concept with a breathtakingly bold objective: to build a spacecraft capable of chasing down and intercepting the next Oumuamua. The technical challenges are almost beyond comprehension, requiring us to launch a probe at incredible speeds with almost no warning. But the very fact that serious scientists and engineers are designing this mission is a testament to the profound impact of our first visitor. We missed our chance to see Oumuamua up close. It was a historic failure of imagination and readiness. Project Lyra is our solemn vow that we will not make the same mistake twice. This is a fundamental shift in our posture towards the universe, from passive listeners to active explorers and, potentially, salvagers of ancient cosmic history. This new scientific imperative will inevitably create new centers of power and ignite new global tensions. The question of how this knowledge will shape our society has two very different potential answers. The first is the optimistic path. For decades, astronauts have spoken of the overview effect, the profound cognitive shift they experience when seeing the Earth from space, a tiny, fragile, borderless blue marble suspended in the void. It is a perspective that makes national rivalries and petty conflicts seem tragically absurd. The confirmation of extraterrestrial intelligence could be the ultimate overview effect for all 7 billion of us. The realization that we are not alone, that we are all Earthlings in a vast and populated cosmos, could be the very catalyst we need to finally achieve a sense of global unity. It could force us to see our shared challenges, like climate change and disease, not as national problems, but as species-level issues that must be addressed collectively if we are to survive and take our place on the galactic stage. In this future, the legacy of Oumuamua is peace. It is the beginning of a truly planetary civilization. But there is a darker path. The lessons of human history are stark. New frontiers and new technologies have always created new conflicts. The discovery of a new continent led to centuries of colonial exploitation. The splitting of the atom gave us clean energy, but it also gave us the specter of nuclear annihilation. An extraterrestrial artifact, even a derelict one, would represent the single greatest technological prize in human history. The science of a light sail, the materials it's made from, the power source it might contain, these could unlock technologies that would give any single nation an insurmountable military and economic advantage. This would trigger a new space race, one with stakes infinitely higher than the race to the moon. It would be a frantic, zero-sum game to secure the technology of the others. In this scenario, the silence of Oumuamua is not interpreted as a benign curiosity, but through the terrifying logic of the dark forest. The artifact is not a message of hope. It is a weapon waiting to be claimed. Its legacy would be the extension of our terrestrial conflicts into the heavens, a militarization of space that could lead to our ultimate self-destruction. The artifact wouldn't save us. It would simply give us a more powerful gun to point at ourselves. And finally, what of the impact on the individual, on the human soul? A populated cosmos would rewrite our oldest stories. Our religions, our mythologies, our philosophies have, at their core, a story about humanity's special place in the universe. How do they adapt? Does the discovery of the others invalidate these ancient beliefs? Or does it expand them? Does God become a god of the entire galaxy? Is creation vastly more complex and wonderful than we ever imagined? New belief systems would undoubtedly arise. Cults might form, worshipping the messengers from the stars, a kind of cosmic cargo cult for the 21st century. Our art, our music, our literature would be forever changed, infused with a new sense of both wonder and dread. What songs do you write when you know for a fact that other beings have seen other stars? What stories do you tell? But perhaps the deepest impact is a psychological one. To live your life knowing that humanity is not the apex of intelligence, that we are likely a very young, very primitive species in a cosmos filled with far older and more advanced minds, is a profoundly humbling experience. For some, it may lead to a sense of nihilism and despair, a feeling of utter insignificance. For others, it could be the ultimate liberation, a release from the crushing pressure of being the sole custodians of consciousness in the universe. It could inspire a new renaissance of creativity and curiosity, a desire to grow up, to learn, and to one day be worthy of joining a galactic community. Oumuamua's ultimate legacy, then, is not an answer, but a question. It passed silently through our home, holding up a mirror to our civilization. And in that mirror, we saw all of our potential for greatness, our insatiable curiosity, our capacity for unity. But we also saw our fears, our tribalism, our scientific dogmas, and our potential for self-destruction. The silent messenger has come and gone. The impact it leaves is not a crater in the ground, but a question seared into the human consciousness. Now that you suspect you are not alone, what will you become? Our investigation began with a simple anomaly, a faint point of light moving too fast, following the wrong path. It was a ghost in the celestial clockwork, a messenger from the void we named Oumuamua. This single object has taken us on a journey, not just across the solar system, but through the very heart of what it means to be human in the 21st century. So, after examining the evidence, where does our investigation leave us? We have reviewed the case file from every angle. We began by looking inward at the terrestrial context and found a civilization caught between a renewed sense of cosmic wonder and a deep-seated fear of the unknown. We were a species desperately hoping to find we were not alone, yet terrified of what that discovery might actually mean. We then turned our gaze outward to the cold, hard facts of the case, the celestial clues. We found a passport from another star, an impossible shape, a frustratingly clean and inert body, and a phantom engine, a mysterious acceleration that defied any conventional explanation. This was the central paradox, the locked room mystery of the cosmos. Our investigation reached its turning point when we connected these two worlds. We proposed a thesis that the deafening statistical silence from our new all-sky surveys, like Atlas, was the key piece of evidence. By failing to find any other objects like Oumuamua, these systems have systematically weakened the case for a natural origin. The argument that it was just the first of many is fading with each passing day. The data suggests Oumuamua was not the prototype of a common natural object, but a genuine, one-of-a-kind anomaly. This led us to the climax of our story, the staggering impact of what it would mean to accept the alternative. A revolution in science, a potential restructuring of global power, and a philosophical recalibration of our place in the universe. So what is the final verdict? Science, at its best, is not a book of answers, but a method of inquiry. It demands that we follow the evidence, especially when it leads to uncomfortable conclusions. The final verdict of this investigation is not that Oumuamua was definitively an alien spacecraft. Such a claim would require a piece of the object in a lab. But the verdict is this: the weight of the evidence, particularly the mounting statistical data, has shifted the balance of probabilities. The artificial origin hypothesis is no longer a fringe speculation. It is a robust, parsimonious, and deeply intriguing explanation that elegantly resolves all of the available data. The Oumuamua conspiracy was never about a government cover-up. It was about a conspiracy of thought, a cognitive friction between uncomfortable data and established scientific dogma. The legacy of Oumuamua is that it has forced this friction out into the open. It has challenged the scientific community to confront its own biases and to consider that the search for life might not end with a radio signal, but with a piece of driftwood from a distant cosmic shore. The burden of proof is shifting. The question is no longer just, can you prove it's alien? It is now also, can you find any evidence for the new classes of natural objects you must invent to explain it away? Until that evidence is found, the artificial hypothesis remains standing, not as a wild guess, but as a sober interpretation of the facts at hand. In the end, this entire investigation is but the latest chapter in the most ancient of human stories, our eternal relationship with the stars. Long before we had telescopes and spectrographs, our ancestors gathered under the same canopy of night. The builders of the Great Pyramids and the monolithic stones of Stonehenge aligned their sacred structures to the solstices and the stars, weaving the cosmos into the very fabric of their power and religion. The ancient navigators of Polynesia learned to read the star paths, turning the entire Pacific Ocean into a map they could hold in their minds. For all of our ancestors, the sky was not a void, it was alive. It was a source of meaning, a calendar, a compass, and a god. It held the answers to the fundamental questions. Where did we come from? How should we live? What is our destiny? In our modern, light-polluted world, it is easy to forget this heritage. But what are we doing if not the very same thing? We have swapped our stone circles for radio arrays, our myths for mathematics, but the impulse is identical. We are still looking up, searching for patterns, seeking meaning, and asking those same timeless questions. The story of Oumuamua is proof that this ancient connection is not broken. The sky is still the ultimate source of mystery. It can still humble us, inspire us, and force us to question everything we think we know. Our connection to the stars is not just a philosophical one. It is written into our very biology. We are, as the late great astronomer Carl Sagan reminded us, star stuff. Every atom in our bodies, save for the primordial hydrogen, was forged in the heart of a star that lived and died long ago. We are the legacy of a cosmic ancestry. We are the heritage of the stars. In this sense, we are the universe made conscious, and our relentless, multi-generational investigation of the cosmos is simply the universe's way of trying to understand itself. Oumuamua has vanished back into the interstellar night, never to be seen again. But it has left an indelible mark. It was not an ending. It was a beginning. It was a single cryptic sentence from a vast cosmic library we have only just discovered. It has bequeathed to us a new purpose and a new urgency. It has inspired a new generation of scientists to build the tools, like the Galileo project, that will actively search for our cosmic neighbors, and to dream of audacious missions like Project Lyra that will one day allow us to reach out and meet them. The greatest legacy of that silent messenger is the gift of a grander perspective. It reminds us that our world is not the world, but one world of trillions. It suggests that human history may be just one page in a galactic story of unimaginable scope and antiquity. The investigation continues. The silent, star-filled sky is no longer a backdrop. It is an active crime scene, filled with clues waiting to be discovered. There will be other messengers. There will be other mysteries. And our job, as the inheritors of this starry legacy, is to be ready, to keep our eyes, our minds, and our imaginations open. For our story is written not on the fragile soil of this one world, but in the vast, eternal, and shared heritage of the stars. And we have only just learned how to read the first page.